Hello, I did it again. I forgot to change that to a 3. Yep. Okay, hello, we're in 7-3 logarithmic functions. In this case, we're going to be looking at example 4, where we're going to start graphing logarithmic functions. And we're going to do this by remembering that these are inverses of the exponential function. So let's talk about this first example here. And probably should have moved it over here, but that's fine. That's fine. So I've got two functions. The one in blue is my exponential function, y equals 2 to the power of x. You can see it right there. My red function is the inverse of that. So the base is 2, so I write log base 2. The logarithm is the exponent, so actually we would write my x, my outcome is y, so I put the y there, and then that equals x. But remember, when we talk about inverses, after we rearrange things, then we switch the x and the y. Okay? So this is log base 2 of x equals y. And I know that that's confusing, and sometimes it's just good for me to like kind of just sweep it under the table and just not even deal with it. But just remember that these two are inverses of each other, and when I have inverses, the input of the original function becomes the output of its inverse, and vice versa. The output of the that's where the versa comes from, by the way. The output of the original function becomes the input of the other one. All right? So yeah, I know, but it's easier to do than it is to think about. I get this. I actually, I think that what happens is when we do it, it's people understand what they got, and then we confuse them. So I'll help you through it. For this picture right here, just remember that they drew this line. The equation of that line, if you remember, is y equals x. So on this, and it's a dash line, so it doesn't get confused with a function, then this line right here, each x value is like 5. Oh, sorry, that would be 6. I'm sorry, I forgot it was going by 2's. So here's my x value 6, and this is 6, 6. X equals 6, y equals 6. This one is right here, 12, 12. So these are reflections of each other because I switched the x and the y. That's what happens with that. Okay. So how's this going to help? And that's, to be honest, having that discussion is one of those things where I'm not going to be very successful in talking about it in a video, so that's where I'm going to save it for class. Okay? But how does this idea help? So let's say I want to graph this one. I know I've already got it here. I'm going to back up and show you how I got it. Well, first I have to graph this, and I'm going to make a vertical table. Here's x, and here's y equals 2 to the power of x. And if you remember from 7.1 when we did exponential functions, I did a lot of horizontal tables. That's fine, don't worry about that. So let's pick some numbers here that I got. Let's say -4, -3, -2, -1, 0, 1, 2, 3, 4. Okay, and actually that's just going to be between these two, but it'll be okay. What did we know from making a table of exponential functions? Well, first of all, any number to the 0 power equals 1. And then I'm going to finish these with the positive exponents. So 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8, and 2 to the fourth power equals 16. These are the powers of 2. For the negative exponents, I take the reciprocals of these, except 1, I didn't mean to point to 1, but I take the reciprocal of 2. This becomes 1/2. The reciprocal of 4 is 1/4. 1/8. Hopefully I got enough room here. And this is going to be 1/16. So let's look on the graph and see what I got here, right? -4 gives 1/16. That's right here. And you can't really tell, but it's actually just a little bit above the x-axis. -3, which is right here, is 1/8. And then -2 is 1/4. -1 is 1/2, which is right here, And then at 0, I got 1. So that one's right there. That one's a little bit easier to see. 1 gives 2. 2 gives 4. 3 gives 8. And then 4 gives 16, which is up here someplace. Now, you're probably wondering, why didn't I pick x equals, I don't know, why didn't I pick x equals 4, 5, 6, 7, 8, 9, 10, 11, 12? Because it goes off my graph. Okay, this is my exponential, this is the table of my exponential function. So I got equation, table, graph. Got it? How do I come up with the logarithmic table? All that I have to do, and I'm going to put these here in a second, all that I have to do is switch the x and the y. So x is -4, y is 1/16. I switch them, right? So I'm going to do that in a second. 1/16 gives -4. 1/8 gives -3. 1/4 gives -2. 1/2 gives -1. I just switched them. Tried to keep them on the same line, but I'm not. Hopefully you guys are okay with that. Instead of 0 gives 1, 1 gives 0. Instead of 1 gives 2, I flip them. 2 gives 1. 4 gives 2. 8 gives 3. And 16 gives 4. Now, usually when we have x values, we choose those. We call it the independent variable. That's why I chose -4, -3, -2, all the way to 4, 3, 2, or 2, 3, 4. I don't know. So this is a little confusing because my x values are kind of weird, but that's simply because I took these and I flipped it. That's all that I did. Okay. Now, after I flip the values, I still call these the independent variable. So this is still x. They're just not the same as those x's because I flipped them, right? And of course this is y, but in this case my function is log base 2 of x. How do I graph it? Well, these are going to be kind of hard. I'll show you where they are, so I'm not going to start with them though. I'm going to start with the easy ones. 1, where x equals 1, I get 0. That's right here. So instead of 0, 1, I got 1, 0. It flipped over that green dashed line. X equals 2, I get 1, so I come over to 2, go up to 1. That's right there. So that flipped to there. X equals 4, I get 2, so I come over to 4, and I go up 2. It's right there. That's the reflection of that. 8 gives 3, so come over to 8, go 1, 2, 3, and that's right there. And 16 gives 4, here's 12, here's 13, 14, 15, 16. 16 is going to be like right about here, off, just a little bit outside my window. And that means that it's going to end up there. And it looks like, don't use arrows, but it looks like that's where the arrow is going to be pointing. Okay? Now, the big question, I'll come back to these in a second. The big question is, what about x equals 3? Well, check this out. This is actually asking 2 to what power equals 3, which is not one of my powers of 2. So that's really confusing. But if I look at my graph, it's there. Here is 3 right here. So whatever that is, it's going to be right there. And I can't tell by my graph, but I might be able to tell once I figure out logarithms, which is going to be really, really cool. Okay, let's go back to where I've got these negative exponents here, which flipped, and I got these fractions. So basically what this is saying is 1/2 gives -1. So, and this is really where it's going to be hard to do with this thick marker. But from here to that dot is 1. So half of it's right there. -1 is right here. And then of course 1/4 of the way comes over a little bit closer, and then it gets a little closer, and then it gets a little closer. All right. For all of these, and we're going to graph a couple by hand, but for all of these, I'm really not, okay, we get a little focused in on, like, do I have it perfect? I don't need you to be perfect. But what I do need you to know is why the things are going where they go. And we worked a lot with this, so all I'm going to do is flip it, exchange the x and the y, and then that's going to give me the inverse. Now, I want to show you something about the TI-84 graphing calculators. All right, turn it on. There you go, clear. Now, I've already got these in there. Notice that we have the common logarithm and the natural logarithm that are like quick buttons. You can get log base b where you can change the base. It takes a while, or at least if there's a shortcut, I need to figure it out. But what you do is you hit the blue button, you go to catalog, and then you scroll down. That has all of the functions that the TI-84 is programmed with in alphabetical order. So you have to go almost halfway where the L's are. And then you find one that says log base. And that's what I did. This is why Desmos is actually a little bit better, but that's okay. I just want to show you something like this. So here's my, I did that first, doesn't matter. Here's my 2 to the x power, and here's my log base 2 of x. So basically these. Let's graph them and see what it looks like. All right, so that kind of looks like that. But here's the problem. This red graph goes forever, and it snugs up right next to the y-axis. Just because, remember, it's a reflection of the blue graph. The blue graph goes forever to the left, and it never touches the x-axis, but it gets really, really close to it. That's actually called an asymptote. And asymptotes are going to be very, very important as we study more advanced functions, right? They're important right now. So the y equals 2x has an asymptote of the x-axis, also known as y equals 0. But I flip that, the log base 2 of x has an asymptote of the y-axis, because it flipped from the x-axis to the y-axis, which becomes x equals 0. You can't tell that from the TI-84. It looks like it stops about right there. And in class, when we had tests where we handwrite our graphs, I've had a lot of students just draw that part and then they stop. And I'm like, yeah, I know what you did. You just copied it from the calculator. 0 points. So I want you to be aware that there are limitations to what the calculator does. Okay, so that's all cool. How do I actually use that for like a different problem? So what we're going to do, here's the steps. This is, my function is going to be f of x equals 3 to the power of x, so that's my powers of 3. Then I'm going to reverse or exchange the x and the y. I'm trying to find other words to say. And then that's going to give me my logarithmic function. Okay, so we want to do x equals -2, -1, 0, 1, and 2. Those are just the ones we want to pick. We can obviously choose more if we need to make more of our graph. So here's x, and here's f of x, come on, f of x, which equals 3 to the power of x. So basically my powers of 3. -2, -1, 0, 1, 2. I almost started with -3, but then I forgot that they want me to do these. 3 to the 0 power equals 1. 3 to the first power equals 3. And 3 to the second power, also known as 3 squared, equals 9. You should know that by now. These two are the inverses of these, the reciprocals of these two. Technically, they're called multiplicative inverses. That's why I slipped up. So this is 1/3, and this is 1/9. I'm just grabbing a couple of different colored markers here in case I need them. Okay, probably should have had that plan. So let me graph this. 0 gives 1, and notice my scale. I go from 0, 1, 2, 3, 4, 5, all the way. So here's 0, 1. Here's 1, 3, 1, 1, 2, 3. And then 2, 9, I'm going to come over 2, and I'm going to go up to 5, then 6, 7, 8, 9. It's going to be up here someplace, but it's off my grid. That part of the graph is going to look like that. And again, never vertical, never perfectly vertical. It still goes to the right. For the left side, -1 gives 1/3. So this is going to get a little tricky. X equals -1 is right here. This is +1. 1/3 is not halfway. That's half is right here. 1/3 is going to be about right there. And -2 1/9, that's really going to be real close. So on the other side, it's going to come down and get really close to the x-axis. I tried to avoid touching it, but it is a kind of a thick Sharpie. So I tried to leave a little bit of space in there. If I did this with Desmos, you're probably not going to see it until you zoom in. There. So pretend there's a little bit of space there. But it never crosses it, and we know there's a limitation to how I can draw, but we know with the infinite imagination that we have with math that we know that it's actually never going to be 0. Okay? So far so good. Now we're going to do the inverse of that. So on the inverse, I still have independent and dependent variable. I'm going to take these x and y's and I'm going to flip them. So x is going to be 1/9, and that's going to give me -2. X is going to be 1/3, and my y is going to be -1. So I just switched them. I'll get 1, 0, 3, 1, and 9, 2. So now I'm going to graph it, and I'm just to be cool, I'm going to switch a different color. All right. So the fractions are a little hard. Do the ones that are easy. It doesn't matter. 1 gives 0, so I come over 1, 0 right there. 3 gives 1, so I go 1, 2, 3, up 1. And 9 gives 2. Okay, so I go 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, that's going to be off my grid. So I know that this, it's going to be somewhere over here, maybe off my paper. I know that this one is going to look something like that. Maybe I can do this. 1/3, -1. That means I'm going to go 1/3 to the right and down 1. That's about right there. And 1/9, -2. 1/9 is barely anything, and that's going to go right there. So the rest of this graph looks like this. And again, I've got this chunky marker. I'm trying to avoid touching that y-axis, but obviously, like I said a moment ago, there's limitations to my ability to draw. So check this out. These two are reflections of each other. So are these two, so are these two, so are these two, and the one that I can't draw, I was wondering where the last one was, the one that I can't draw because it's off the grid. So again, we already know how to do the exponential function. Make a table flipping the x and y, and then just plot it. Let's try another one. And one more time, this is an example where the fraction is going to make it a lot easier. I know you want to grab a calculator and do this with the decimals, but it'll be okay. So here's my x. Come on. And here's my function f of x, which equals 0.8 or 8/10 to the power of x. I'm going to call that 4/5 to the power of x. Why? Because I know the powers of 5 and I can figure out the powers of 4. The powers of 0.8, that might be a little tricky. I'm supposed to use -3, 0, 1, 4, and 7. Okay. -3, 0, 1, 4, and 7. Okay. 0 is easy. Any number to the 0 power just equals 1. 1 is easy. Any number to the first power is just that number. So those two are easy. Let's talk about 4. I'm going to write it down here. 4/5 to the power of 4 means 4 to the 4th power over 5 to the 4th power. 4 to the 4th power is going to be 4 times 4 times 4 times 4. I can pair them up. 4 times 4 is 16. The other two, 4 times 4 is 16. So I get 16 times 16, which is 256. 5 times 5 times 5 times 5 would be the same as 25 times 25, which is 625. So this is going to be 256 over 625. All right. Now you're probably thinking, why do I have to do this? Because I know you can do that much in your head. The next one's going to be a little hard. You could have perfectly just done this. 0.8 to the 4th power. And I got 0.4096. How do I know that's the same? Because 256 divided by 625 gives me the same number. Right, so again, forgive me, I'm trying to do as much as we can within your head, your brain. Trying to make your brain powerful. 7, sure, you can do 4 to the 7th power, do 4 times 4 times 4 times 4 times 4 times 4 times 4, and then do the same thing with 5 and get the fraction. Okay, 0.8 to the 7th power, that one gets nasty. So we'll say 0.20975152. There's no way I'm going to graph it that accurately. So we'll just say it's a little bit bigger than 2/10. Negative 3, if I had, they didn't tell me to do 3. If I'd had 3, which, and actually I can do this, 4, come on marker, 4 over 5 to the 3rd power is 4 to the 3rd, which is 64. Over 5 to the 3rd power, which is 125. So 4 over 5 to the negative 3rd power, I switch these. It's a reciprocal, 125 over 64. You didn't see any of that because I didn't move my paper up high enough. So 125 divided by 64, I can also do 0.8 to the negative 3 power, and I get the same thing. So it's really about being able to understand how these things work. It's not about getting the answers, guys. It's really not. It's about understanding how you get it. So I can say 125 over 64, or if you want to say it's about 1.9. Okay, cool. If I graph that, negative 3 gives me about 1.9, so I'm going to go 1, 2, 3. That's just under 2. So that's just about right there. And of course, I drew it nice and thick, so I don't have to be perfect. 0 gives 1. 1 gives 4 over 5, which is just below 1. 5 over 5 is 1, so this is just below that, like right about there. 4, all right. Maybe I want a 256 divided by 625. I think I had this up there. Yeah, it's just under 0.4 or under 1/2. So that's about right here. And then 7 is about right there. So that may not necessarily be enough to graph it, but I do know this. I do know that this does not touch, and I bonked a little bit there, but it does not touch the x-axis. And on this side, whoops, didn't mean to bonk it. This side, it does not go perfectly vertical. Probably, I'll tell you what, you didn't need to do this, but I'm trying to draw a nice graph for the video. 0.8 to the negative 10 power is about a little bit bigger than 9. So that's going to be about right there. So there's my target. I'm going to try to curve up to there. There you go. And of course, I'm using a big, thick marker, so it gives me a little bit of a chance to not be perfect. Now I'm going to do the inverse. So here's my x's. Here's my y's for my inverse. I'm just going to switch these two. So again, this is 125 over 64, excuse me, got hiccups. That gives negative 3. 1 gives 0. 4 over 5, or 0.8, I'll go ahead and say 0.8, those are the same, gives 1. 256 over 625, which we saw right there is 0.4096, that gives 4. And of course this one, approximately 0.2, is about 7. It's that. I just didn't want to write it again. How do I graph this? All right, so remember 125 over 64, oops, clear, 125, didn't hit the 1. That's a little bit less than 2. So I'm going to come over to 2, just a little bit before that, and I'm going to go down to -3. That's about right there. 1 gives 0, so I go over 1, 0. 0.8 gives 1, so I'm going to go up, and this one's going to get, it's right here, and it gets a little crowded in this area. Remember, this is about halfway, it's about 0.4, so I'm going to come over halfway and go up here, and then 0.2 is 7, that's about right here. So this part of the graph, and let me switch colors here real quick. This graph is going to look like so, and that extra one I had right here, which was -10, what did I say it was, -10 and a little bit bigger than 9, so it's going to be about right here. Okay, so that one does this, and if you kind of check this out a little bit, where'd my other marker go? There it is. If you kind of check this out a little bit, I still have this reflection, this mirror line right here, where the black graph got flipped over and made that reddish graph. Okay, we will be exploring more of this when we get to the section about transformations of functions, but this is just enough to get you started.